Hello everyone. Today we are going to study the chemical reactions of carbon compounds. The first reaction is combustion reaction. What do you mean by combustion reaction? When any substance is heated in the presence of oxygen, it creates extra amount of heat while burning. When carbon is heated with the oxygen, it generates carbon dioxide with extra amount of heat. This is what the burning of coal or charcoal. When the carbon compound methane, that is CH4, is heated in the presence of oxygen, it also creates the extra amount of heat with the byproducts H2O and CO2. When the ethanol, that is ethyl alcohol C2H5OH, is heated in the presence of oxygen, it also creates the heat and the byproducts H2O and CO2. Almost all the carbon compounds are the good fuels. Next type of reaction in the carbon compounds is substitution reaction. It happens with alkenes, that is saturated hydrocarbons. When the hydrogen is replaced by any other halogen, that is what called as substitution reaction of the alkenes. Here we are going to study the example of methane when it reacts with chlorine in the presence of sunlight or UV light. As shown in the figure, it displaces one hydrogen from the methane and chlorine is substituted at its place. The CH3Cl is formed with the byproduct HCl. If this CH3Cl, that is chloromethane, is reacted again with the chlorine in the presence of UV light or sunlight, again one more hydrogen is displaced. It is substituted by again another one chlorine atom and CH2Cl2 is formed. Again this CH2Cl2, that is dichloromethane, is reacted with Cl2 in the presence of UV light. One more chlorine atom is substituted at the place of one more hydrogen and the new compound, that is CHCl3, trichloromethane, is formed. In day-to-day life, this trichloromethane is also called as chloroform. When this chloroform CHCl3 is again reacted with chlorine in the presence of sunlight or UV light, one more hydrogen atom is substituted by chlorine atom and CCl4, that is tetrachloromethane, is formed. Next type of reaction is addition reaction. This reaction is done with unsaturated hydrocarbons as those contain the double or triple covalent bonds. At once, in this addition reaction, one of the double or triple covalent bonds is broken and at that place two hydrogen atoms are added. As shown in the figure, alkyne is converted into alkene by adding two hydrogen atoms and alkenes are converted into alkane again by adding two hydrogen atoms. As shown in the chemical reaction, at first we have taken alkyne, that is ethine, in which the two carbon atoms are connected with each other by three covalent bonds. At first, one from the triple covalent bond is broken and the two hydrogen atoms are added at that place. As shown in the chemical reaction, ethine is converted into double covalent bond ethene. This reaction is done with the help of platinum or nickel catalyst. The concentrated HCl is used to provide the H2. In the next reaction, that is of the conversion from ethene to ethane, the double bond between the two carbon atoms is broken and the two hydrogen atoms are added at that place. The next type of reaction is oxidation reaction, in which we are going to study the oxidation of ethanol. The ethyl alcohol C2H5OH is added with the oxygen and it is converted into acetic acid, that is ethanoic acid CH3COOH. Here in this reaction, the two types of catalysts are used. KMnO4, that is potassium permanganate, or K2Cr2O7, that is potassium dichromate. Concentrated H2SO4 is used over here to supply oxygen atoms for the oxidation and to remove hydrogen atoms. In this reaction, the two hydrogen atoms are removed and double bond oxygen is added to the carbon atom.